You wake up at 3 a.m. to the sound of your cat purring. It's soft, rhythmic, almost comforting. But there's something hidden inside that sound, something your cat evolved specifically to put there, and your brain has absolutely no defense against it. This isn't a metaphor. It's something researchers were actually able to measure. And once you understand what's actually happening when your cat purrs at you, you will never hear that sound the same way again. Start with what most people think a purr is: a sign of contentment. A cat that's happy, relaxed, comfortable. The audio equivalent of a smile. That's partly true, but it's only half the picture. In 2009, researcher Karen McComb at the University of Sussex decided to study something that had been bothering her for a while. Her own cat had developed a particular purr, one she used specifically when she wanted food. It sounded different, more insistent, harder to ignore. McComb wanted to know why. What she found changed how scientists understand the relationship between cats and humans entirely. She recorded two types of purrs from the same cats, one made during relaxed, non-demanding moments, and one made when the cat was actively soliciting food. Then she played both recordings to 50 volunteers. Some were cat owners. Some had never owned a cat in their lives. Every single group rated the food-soliciting purr as more urgent, more unpleasant, harder to ignore. And here's the part that stopped researchers cold. Even the people who had never owned a cat responded the same way. This wasn't learned behavior. This wasn't a conditioned response built up over years of living with a pet. This was something deeper, something that activated in people who had no prior relationship with cats at all. Then researchers analyzed the sound itself. That's when everything changed. The solicitation purr, the one cats use when they want something, contains a hidden component. Embedded within the low, familiar rumble of the regular purr is a high-frequency element, a cry tucked inside the contentment. That cry sits in the frequency range of 220 to 520 Hz. Human infant cries sit in the range of roughly 300 to 600 Hz. On a graph, the two ranges almost sit on top of each other. The overlap is not accidental. Your brain is wired, at a deep biological level, to respond to the distress signals of human infants. This wiring exists because ignoring a crying baby has always carried serious evolutionary consequences. The response is fast, almost reflexive, and crucially, it operates below the level of conscious reasoning. Cats found that frequency. They embedded it in a sound you already associate with comfort and safety. And they pointed it directly at the part of your brain that cannot say no to a crying child. But then researchers made a discovery no one expected. When they edited out the embedded high-frequency component, leaving the rest of the purr completely intact, the same listeners judged it as significantly less urgent, less demanding, easier to ignore. The regular purr, on its own, didn't trigger the same response. It was specifically that hidden cry, that single embedded frequency, doing all the work. Remove it, and the purr becomes background noise. Keep it, and it becomes something your brain treats with the same priority as a distressed infant. Your cat knows the difference, and it uses that knowledge every single time it wants something from you. But the manipulation doesn't stop with sound. Researchers also discovered that cats don't use the solicitation purr indiscriminately. They learn when it works. Cats living alone with a single owner were significantly more likely to develop this vocalization than cats in large multi-person households. The more direct access a cat has to one human, the more time they spend together, the more precisely the cat tailors the sound. If one version of the sound gets breakfast 5 minutes earlier, evolution remembers. This isn't rigid, pre-programmed instinct. It's behavioral refinement, trial and error conducted quietly at the expense of your sleep schedule. And the manipulation doesn't stop with sound. Then scientists noticed something no one had looked at closely before. Domestic cats look different from their wild ancestors in ways that are not accidental. Modern domestic cats have shorter muzzles, wider eyes, rounder faces. These are the same physical features that humans associate with infants, features that trigger what psychologists call the cute response, a release of neurochemicals in the human brain associated with caregiving. Cats didn't acquire these features randomly. Humans consistently provided more food, shelter, and protection to cats that looked this way. Over thousands of years of selective pressure, domestic cats evolved to more closely resemble human babies, not because it helped them hunt, but because it helped them survive alongside us. Over thousands of years, they quietly turned themselves into something your brain finds almost impossible to ignore. There's one more layer to this, and it runs in both directions. When you pet a cat or make sustained eye contact with one, your brain releases oxytocin. This is the same hormone that bonds mothers to their infants, the same chemical that surges during moments of deep human connection. Your cat triggers it, and cats, it turns out, experience the same response. Oxytocin levels in cats rise when they interact positively with their owners. The bond isn't one-directional. The neurochemistry runs both ways, which means the manipulation, if you can still call it that, is more complicated than it first appears. There is something genuinely strange about this relationship when you look at it plainly. Cats are not domesticated the way dogs are domesticated. Dogs were bred by humans, deliberately, over generations, for specific traits. Dogs were shaped by us. Cats are largely self-domesticated. They chose to move closer to human settlements, drawn initially by the rodents that gathered around grain stores. Humans tolerated them, then fed them, then welcomed them inside. The cats that were better at reading humans, better at triggering the right responses, better at making themselves indispensable, were the ones that survived and reproduced. The cats alive today are the descendants of the ones who were best at this. Every purr your cat produces, every slow blink, every deliberate act of proximity, is the result of thousands of years of selection pressure. A long, quiet experiment in how to make one species necessary to another. For thousands of years, one small predator learned that strength wasn't the fastest way into a human home. Understanding the human brain was. And somehow, it worked, even at 3 a.m.